So in this video I'm going to talk about carbohydrates and lipids. Now the first thing you have to know about carbohydrates is, well, first I'll discuss carbohydrates. So carbohydrates are made up of carbon, hydrogen, and oxygen. Now carbohydrates, I find they're special in a chemical sense because they all have like a relatively uniform structure because they're all structured in a similar manner. Now, what do I mean by that? Let me explain. So, carbohydrates are made up of polysaccharides, oligosaccharides, monosaccharides, and disaccharides. So, what these words mean, in these words they indicate, like the prefixes to the words, they indicate the number of glucose units in a carbohydrate, except for oligosaccharides and polysaccharides, because oligosaccharides, they're carbohydrates that have between 3 to 9 monosaccharides. And polysaccharides are really, really long chains of monosaccharides, and they're even longer than oligosaccharides. Now, oligosaccharides, they weren't at all important to the test in my case, but they may come up, so it helps to know the difference between polysaccharides and oligosaccharides. Now, a glucose unit or a monosaccharide, well, I call it a glucose unit because it's the monosaccharide. An example would be glucose, which is C6H12O6. So sucrose, aka table sugar, and dextrose are examples of disaccharides because they have two glucose units, and their formulas are. So why is it not? So you might be asking yourself, why don't they have 24 hydrogens and why don't they have 12 oxygens? So this is called the dehydration synthesis to bring together two monosaccharides, which means that basically you extract a water molecule from you extract one water molecule from the monosaccharide, and you add it up, and then so basically this formula, it's C12H24O12 minus H2O, which makes the H22 and O11 that you see. And that's the result of dehydration synthesis. And that goes on and on and on for like polysaccharides. Now, polysaccharides are basically, like I just explained, they're carbohydrates that are composed of a lot of monosaccharides or glucose units, and examples of that could be starch and glycogen. Now, these substances are used in plants and animals respectively as a mean of packing a lot of glucose molecules together all in one place to efficiently store space. And the organisms do this to store energy for later use, but it's more accessible than fats. So glucose, it flows freely through the veins of every animal to fuel our every action. Now, glycogen is formed from free-flowing glucose by insulin, a hormone when the body feels that there's too much glucose flowing in the blood. Glucagon is another hormone which does the opposite. It releases glucose from your glycogen reserves to the bloodstream so that it can be used as a readily usable system of it can be used as a readily available source of energy. So ending carbs with hormones is a good way to transition into lipids, since hormones are a type of lipid. Now, lipids are composed of carbon, hydrogen, and oxygen, much like carbohydrates, but they don't follow the glucose unit rule I showed you earlier. Lipids, they also tend to have more complex chemical formulas and structures than carbohydrates. So what this means is that they take more energy to break down than carbohydrates. And this is why the body tends to burn fat after exhausting its reserves of glucose. Triglycerides are a kind of fatty acid, are the fatty acid that our body oxidizes for energy with the help of the lipase enzyme. Saturated fats have hydrogen all around the fat chain, so it's like, let's say, now, unsaturated fats, they don't have hydrogen all over the place, and instead they form double bonds with, maybe they can form like a double bond here, but there's like, maybe we can pretend that there's like hydrogen, hydrogen, hydrogen. My H's are horrible. Hydrogen, 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 hydrogen. You get the idea. Anyway, so because of this double bond, there's a kink. That kink in the structure makes unsaturated fats liquid at room temperature. Now, lipids overall are nonpolar substances, which means that they're insoluble in water. So that's why when you put olive oil and water together, that's why you see the olive oil floating above the water. Now, phospholipids are another important class of lipids. Phospholipids are a special kind of lipid because it has a head and two tails. The head carries a negative charge, and the tails have a neutral charge. Now, what does this mean? It means that the head is hydrophilic, which means that it attracts water due to its negative charge. Hypothetically, if it had a positive charge, it would attract water also because the hydrogen, well, what attracts the water to the head, it's the hydrogen ions. It's the hydrogen atoms in water because they have a positive charge. And so, and now the negative charge, it attracts the hydrogen, but if it had a positive charge, the oxygens in water would be attracted, and either way would create a hydrophilic effect. Now, since the tails are neutral, if anything, they repel water because water, it would just collide with it. So this property of repelling but also attracting water at the same time makes phospholipids a useful part of a cell membrane, which Mao is going to cover in one of his videos. Make sure to watch it if my videos are a little boring for you. I hope you liked my video. Like and subscribe to show your love for a YouTube rookie.